So in this standard, we look at in first grade, how do we solve problems when the unknown is in any position? So this is our 1.5F. This says kids have to determine the unknown whole number in addition or subtraction equation when the unknown could be in any one of the 3 or 4 terms in the equation. Now, we call this start unknown, change unknown, or result unknown. So it's the situation where kids have to solve when the unknown isn't always just result unknown. And that's our favorite one. I've got some word problems here to help us make sense of the difference between these 3 problems. So a result unknown is the one we're all most familiar with, and we like it because we know how to teach it, it makes sense to kids, and it's not a tough concept. So Terry had 8 pencils. She gave 3 away, so I know when I give something away, that's subtraction. How many does she have now? That's result unknown, because I'm finding the result of whatever happened. That's the result unknown. And we know how to model it. We could say we had 8, 7, 8. I took 3 away. My result is 5. My result is unknown. So this is the one that we are all most comfortable with and kids are most comfortable with. That's not one that tends to give us a lot of trouble. It's what they've seen forever. So that one doesn't bother us. The next one I want to look at is change unknown. And we're going to save start unknown for last. So change unknown, Terry had 8 pencils. She gave some away. Now Terry has 5 pencils. So if I was writing that in equation, it would look like Terry had 8 pencils. She gave some away. I don't know how many, but now I have 5. So here I have change unknown. I don't know how many she gave away, but I could model it. So again, if I had 8, 5, 6, 7, 8, and I gave some away, I don't know how many I gave away, but I have 5 left. Well, if I take 1 away, do I have 5 left right now? No, I have 7. If I take another one away, do I have 5 left right now? No, I have 6. If I take another one away, now does Terry have 5 pencils left? Yes, Terry has 5 pencils left. So how many did I give away? I gave away 3. So I can model it, I can write it in an equation, I can make sense of it with the problem, and I can do it step by step with small numbers so that kids are making sense of it. Then we can move to larger numbers. And last is start unknown. Terry had some pencils. I don't know how many. Had some pencils. What happened? I gave 3 away. Now what do I have? I have 5. So this is called start unknown. I don't know what I started with. In the problem, I'm not told what Terry started with. I'm asked to figure out what Terry started with. So let's start with what we know. Terry has 5 pencils right now. 1, 2, 3, 4. Here's the 5 pencils Terry has right now. Well, what else happened? I gave 3 away. Well, what would have happened if I never gave those 3 away? Here's the 3. What if I got them back? I never gave them away. How many did I have? I have 8 now. Can we make sense of that with kids? Well, let's check it. If I had these 8 pencils and I gave these 3 away, do I have 5 now? Yes, so I know that I started with 8, and I do that using the strategy working backwards. So I start with, what do I know? I know that now I have 5 pencils. I gave 3 away. Well, if I'm working backwards, what if I didn't give those away? Then that means I would still have them. So if I didn't give them away, how many did I start with? I started with 8, gave 3 away, and now I have 5. So this is start unknown, change unknown, result unknown. And I will tell you, every time I go in a first grade class and a teacher says, oh, my kids are doing so great with word problems, they get it, they get it. And I say, have you done start unknown or change unknown? And they go, yeah, we did that. It worked great. And when I give them some sample problems like this, kids struggle with it. So you've got to do a variety of problems, and we're going to go back to that concrete. We've got to do it concrete before we expect them to do it pictorially and then abstract. Remember, the equation is always abstract. So pictorially, we could draw it. We could draw the pencils. We could draw sticks for pencils. We could create a part whole model or a strip diagram. We could create a number bond to help them see how all the parts work together. If I created a number bond of this, then it's easy to see what operation to use. So here are my parts of my number bond. I gave some away. Was this the total, or is it one of the parts? It's one of the parts. I have 5. Now, after I gave some away, I have 5. Is that the total that I started with, or is that a part? That's a part. So now I can see that I have to put these together to get the unknown. Here, trying to make sure I'm writing on the paper. Here, I had a total of 8 pencils. That's what I started with. I had 8 pencils. I gave some away. Is the sum I gave away a part of it, or is it all of it? Well, I only gave away part of it because I have some left still. So I can see that when I'm looking for a missing part, I subtract. And then, of course, we know this one we've done probably 100 times at least by now. And we know that we subtract to find that missing part. Let me know if you need more help with this standard.